In this video, we're going to find the limit as x approaches negative infinity of the absolute value of 2x minus 5 minus x all over 3x plus 2. This limit problem looks intimidating. It has a triple threat, a limit at negative infinity, a fraction, and the dreaded absolute value sign. Most students just jump straight to dividing by x and miss a critical step, leading to the wrong answer. In the next few minutes, I'll show you how to handle the absolute value correctly, making this problem trivial. Let's dive in. Step 1, and the most crucial step, is dealing with the absolute value term. So in this case, the absolute value 2x minus 5. Remember the definition. The absolute value of something is that expression if it's positive, so in this case 2x minus 5, and the negative of that expression if it's negative. So that would be negative quantity 2x minus 5. Our limit is as x approaches negative infinity. If x is approaching negative infinity, x is a very, very large negative number, like negative 1,000,000. Let's test it. If x is negative 1,000,000, then 2x minus 5 is 2 times negative 1,000,000 minus 5, which is a huge negative number. Since the expression inside the absolute value 2x minus 5 is negative, we must replace the absolute value 2x minus 5 with its negative. So that's what we have here, negative quantity 2x minus 5. This is the key step. Now we can rewrite the entire limit problem without the absolute value. So the next step here will be to distribute the negative. We have negative 2x plus 5 minus x all over 3x plus 2. Let's clean up the numerator by combining the like terms. Negative 2x and negative x, that gives us negative 3x, and we keep the plus 5. Now we have simplified the scary looking problem into a standard rational function limit at infinity. When finding the limit of a rational function as x approaches positive or negative infinity, we divide every term in the numerator and the denominator by the highest power of x in the denominator, which is just x to the first power. So now we have negative 3x over x plus 5 over x all over 3x over x plus 2 over x. That simplifies to negative 3 plus 5 over x all over 3 plus 2 over x. And now we apply the limit rule. As x approaches negative infinity, any number divided by x goes to 0. So the x to the fifth term and the x squared term both become 0. So now what we have is negative 3 plus 0 over 3 plus 0, and that's equal to negative 1. And so that's going to be the final answer.